me an opportunity to introduce this resource person. Thank you.
Thank you so much for introducing Dr. Shivayog sir to participants. Sir, can you share your screen and start your presentation, sir. Over to you, sir. Shivayog sir.
Thank you. Javanjay, kindly share the screen, please.
Okay, sir. Just a minute, sir.
Hello. Hello.
Sir, is it visible, sir? I have shared the screen.
Not yet, Dhananjay, sir.
Just a minute.
Here also it is not opening. Visible. Full screen it, please. Good afternoon, everyone. Myself, Dr. Shivayog, Assistant Professor, Seed Unit, University of Horticulture Science, Bagalkot. Today I am going to talk on the topic perspective and problems of synthetic seed production in horticulture crops. Next slide, please. As we all know, the seed is the matured embryo consisting of an embryonic plant protected with seed coat, and it serves several functions for the plants that produce them. Key among all these functions are nourishment of the embryo, dispersal to a new location, and dormancy during unfavorable condition. Next slide, please. There are some limitations with respect to production of natural seeds. Maintenance of genetic purity is very difficult in natural seed production. In crossed and highly cross-pollinated crops like onion, carrot, cabbage, cauliflower, and most of the fruit crop species they will not produce the seeds. And difficult in dioecious plants for female plant in cucurbits, cucumber, seed-borne disease and pest. Some seedless fruits cannot be propagated through seeds, seedless grape and dormancy of seeds in crops like bitter gourd and ridge gourd. Next. For the improvement of crops and their nutritional value, since from decades, research and advancements in biotechnology have presented newer strategies in agriculture, horticulture, and as well as in forestry species. However, plant tissue culture, an important component of biotechnology, brought a different era of plant improvement. Among all the techniques used in tissue culture for the conservation of specific genes and for mass propagation, the somatic embryogenesis techniques gain much popularity because of the formation of an embryo from any somatic cells of the plant. And there is an introduction of somatic embryogenesis in 1950. The introduction of the demand for artificial seeds and led to the concept of synthetic seeds. Murashige, who first named the artificial seed as synseeds, and he defined it is an encapsulated single somatic embryo. Next. When you will briefly discuss regarding this history, in 1982, Kitto and Janik, who first coated carrot embryos with polyoxyethylene to develop artificial seeds. Later, Redarmic and his co-associates in 1984 developed a technique for encapsulation of individual somatic embryos in alfalfa by using the hydrogels like sodium alginate, and Senaratna, McCarthy, and Bowley in alfalfa. Desiccation tolerance of somatic embryos was induced by exogenous application of abscisic acid. Next, please. Then the synthetic seed. What do you mean by synthetic? Synthetic seed is nothing but a living seed-like structure derived from somatic embryos in vitro culture. After encapsulation by a hydrogel like calcium alginate, sodium alginate against microbes and desiccation, also as well for protection of the embryos. Next slide, please. This is the difference between natural seed and synthetic seed. Whereas in natural seeds, after pollination, there will be fertilization take place, and fertilization after fertilization, there is the development of the seed. Whereas in artificial seed or in synthetic seed, you have to take the explants from healthy mother plant and culture for callus induction. After once you get a sufficient quantity of callus, then you will go for subculture of callus for somatic embryo induction and production. Once you get the matured somatic embryos, then singulation of somatic embryos will be taken, and that will be encapsulated by this matrix and hydrogel and go for planting. Next slide, please. High synthetic seed is required in order to overcome low percent survival of an in vitro plantlets during the ex vitro acclimatization. Synthetic seed technology holds much promise, and also in some of the horticulture crops, seed propagation is not successful due to heterozygosity, minor seed size, presence of reduced endosperm, and some orchid seeds require mycorrhizal fungi associated for their germination, and no seeds are formed. These crop species can be propagated by vegetative means like micropropagation and clonal propagation. Next. This is the synthetic seed production technology procedure. You have to select the explant from healthy plant, and then inoculate that explant after sterilization. Sterilization can be done by using various sterilant like mercury chloride, tin 20, sodium hypochlorite, bavistine, and streptomycin, etc. After sterilization, you go for incubation for callus induction. Once if you get sufficient quantity of callus, then you go for subculture of that callus for the somatic embryo production. After getting a matured somatic embryos, then you will go for encapsulation of that particular somatic embryo. Next, please. The selection of plant material for the production of synthetic seed is very important. However, the synthetic seeds can be produced by using somatic embryos or other plant propagules. A specific plant species supports a specific plant material for the production of synthetic seeds. For example, somatic embryos have been successfully used to produce seeds in several plant species that include Oryza sativa, Carica papaya, Dalbergia siso, Curcuma amara, Hibiscus indicus, etc. Whereas some plants support the production of synthetic seeds. When nodal segments are used, it includes Eclipta alba, Cannabis sativa, Gossypium hirsutum, Solanum tuberosum, etc. Next slide, please. Here, somatic embryos are used as a in vitro propagules for encapsulation of papaya in the crop like papaya, brinjal, mango, carrot, sandalwood, brassica, alfalfa, lettuce, celery. Whereas in Vitis species, eucalyptus, citrus, pineapple, auxiliary buds and adventitious buds are used as a in vitro propagules for encapsulation, and shoot tips were used in crops like banana, cardamom, apple, and in kiwi fruit. Next. These are the schematic representation of synthetic seed production. Here first I will tell the production of synthetic seeds by using nodal segments. Then first step you have to select the healthy plant. From healthy plant you have to take the explant of nodal segments and disinfect them by using various sterilants. And after disinfecting, you have to dry the expands and directly go for alternate mixed bar. That means encapsulation of that, and then you go for direct seed sowing or long-term storage in liquid nitrogen or short-term storage. Whereas in where you are using somatic embryos for the production of these artificial seeds, then you have to select a healthy plant, surface sterilization of expands, then you will go for incubation callus induction, from callus induction to somatic embryo production to next encapsulation of somatic embryos, then for direct sowing or long-term storage or short-term storage. This is the schematic representation of synthetic seed production in many of the crops. Next, please. There are two types of synthetic seeds are known, that is desiccated oil and another one hydrated. The desiccated synthetic seeds are produced from somatic embryos, either naked or encapsulated in polyxor, followed by their desiccation. The desiccation can be achieved either slowly over a period of 1 or 2 weeks subsequently using chambers of decreasing relative humidity, or rapidly by unsealing the petri dishes and leaving them on the bench overnight to dry. Such type of synthetic seeds are produced only in plant species whose somatic embryos are orthodox. Whereas in hydrated synthetic seeds produced in those plants species where the somatic embryos are recalcitrant and sensitive to desiccation. Here, hydrated synthetic seeds are produced by encapsulating the somatic embryos in hydrogel capsules. Next, please. These are the some encapsulating material: sodium alginate with gelatin as a gel, carrageenan, locust bean gum, gelrite, and complexing agent were used as calcium salts, calcium chloride, potassium chloride, ammonium chloride. Next, please. The selection of encapsulating material is very important during synthetic seed production. There are some qualities that the encapsulating material should have if it's going to be used for the production of synthetic seeds. It must not damage to the embryo. The coating should be mild to protect the embryo. The coating should be durable for rough handling during manufacturing, storage, transportation, and planting. The coat must contain all the essential growth materials such as nutrients and growth regulators. This is depends upon the coating material, depends upon the researcher objective, and the formed synthetic seed should be transplantable using the existing techniques. Next, please. Why alginate we are selecting? Most of the researcher and most of the producer synthetic seed production technology, they will prepare alginate only because it's a moderate of its moderate viscosity and low toxicity for somatic embryos and quick gelation and low cost, and alginate chosen because it enhances capsule formation and protects somatic embryos against mechanical injury. Some of the research they will use agar, which is inferior to this alginate. Encapsulation methods for synthetic seeds, the drooping procedure. The most useful encapsulation system is drip 2 to 3% sodium alginate drops from the tip of the funnel and the somatic embryos are inserted, and keep the encapsulated embryos complex in calcium salt for 20 to 30 minutes. Here the sodium alginate 2 to 3%, it varies from crop to crop. Some researchers they will use 4%, 3%, 5%. They will use, and the calcium salt for 20 minutes, for 30 minutes, for 40 minutes, depending upon so many researchers they use different timings, and rinse the capsules in water and then stored in a airtight container. Next, please. And another method is automate encapsulation process. This is the quick method of artificial seed production, and this is a costlier one. The alginate solution with embryo is fed from supply tank, that is A, and alginate capsules were planted in speeding trays using a vacuum seeder. The capsules are planted in the field using a Stanley planter. A hydrophobic coating is required for mechanical handling. Next, please. These are some characteristics of synthetic seeds: high volume, large scale propagation method, maintains genetic uniformity of plants. As we selected the expert from the known plant material, healthy plant material, direct delivery of propel to the field, thus eliminating the transplants. Whereas in tissue culture propagated plantlets, we have to deliver the saplings or seedlings to the field. Here this is not necessary. Thus, it will eliminate the transfer delivery of propagules. Lower cost per plantlet, rapid multiplication of plants. Next, please. Merits of artificial or synthetic seeds are easy handling and inexpensive transport, as the size of the seed is very small, hence it is easier to store, transport and planting. Storage life very good, but it requires high-tech storage structures. Product uniformity to avoid extinction of endangered species and seedless plants. It will help to conserve the endangered species. Next, please. Large scale propagation. Once if you standardize the protocol for synthetic seed production in particular crop, it is very much suitable for large scale of monoculture, germplasm conservation, or the use of germplasm conservation in ex situ conservation, allied plant genotypes. These artificial technology preserves, protects, and permits economical mass propagation of allied plant genotypes such as orchids, independent of environmental condition. Or these synthetic seeds are prepared inside the laboratory. It is not a season specific. You can produce synthetic seeds in any season. There is no season specific. Permits direct field use. For tissue culture rice plants, rooting hardening is necessary, but in case of synthetic seeds, direct field sowing can give a good results. Next, please. Supply of beneficial adjuvants like plant growth regulators, nutrients, microorganisms, fungicides, mycorrhizae, and vitamins, etc. These plant can be made available to the developing plant embryo as per the requirements, as these can be added into the matrix. Facilitate studies. It will facilitate the study. Basic steps involved in the synthetic seed technology involve seed pod formation, functions of endosperm in embryo development, and seed germination. Somaclone variation provides wide open facility for the study. It can be applied where seed production is difficult and expensive. Synthetic seeds offer many advantages and opportunities. Next, please. These are some disadvantages. Several intensive researchers in the field of synthetic seed technology were applied in propagating and conserving a number of plant species, but practical implementation of the technology is limited due to the following reasons. Production and storage of synthetic seed is cost effective, hence the production technique itself becomes costlier. Production of viable micropropagules useful in synthetic seed production is less. Anomalous and asynchronous development of somatic embryos. Next, please. All the embryos cannot mature at a time, hence that makes them inefficient for germination and conversion into the normal plants. Seed dormancy is considered as a problem, but due to lack of dormancy and stress tolerance in somatic embryos, the storage of synthetic seeds are limited. The technology of synthetic seed is limited due to poor conversion of even apparently normally matured somatic embryos and other micropropagules into plantlets. Now we'll move towards some of the case studies. Papaya, carico papaya. This experiment was conducted in the University of Horticulture Science, Bagalkote, Shivayog et al. And 2019. Here the source of plant material was taken. Arka Surya is a red blessed variety which is developed by IHR Hisarghatta, Bengaluru, from the cross between Sunrise Solo and Pink Plus Sweet. Next, please. Once you prepare the explant, you'll go for a surface sterilization of the explants by using various sterilants. After steriling, go for inoculation. After for the inoculation for callus induction. After callus induction, you go for somatic embryogenesis. Once you get somatic embryos, then we go for encapsulation in somatic embryos by using 4% sodium alginate with the complexing material calcium chloride with 100 micromolar. Please, next, please. This is the incubation of explant after sterilization for callus induction. Here the induction of callus by using various concentration of 2,4-D and BAP separately. Next please. Once you get sufficient quantity of callus, then we subculture into for somatic embryogenesis by using different concentration of BAP kinetin 2,4-D in MS medium. After somatic embryo production, there is a singulation of somatic embryos. Next, please. The singulated somatic embryos are encapsulated by using 4% sodium alginate and with 100 micromolar calcium chloride compelling as a compelling agent. And after production of synthetic seeds, the synthetic seeds were tested for their viability by using a tetrazolium test. Next, please. Case study number 2, that is in banana. Next, Ganapati and his co-associates in 2000 studied the regeneration of plant from encapsulated somatic embryos in banana cultivar Rastani. Here, somatic embryos are used for encapsulation. The encapsulation is done by using 5% sodium alginate with 100 micromolar calcium chloride. Next, please. This is the emergence of shoot after 2 weeks of culture from encapsulated somatic embryos. Planted development from encapsulated somatic embryos on MS basal medium after 6 weeks of culture. 2-month-old hardened plants derived from encapsulated somatic embryos growing in the polybags. Next, please. Das et al. In 2016, they studied the synthetic seed preparation, germination and plantlet regeneration of Lychee henensis. They used a different concentration of IB for the induction of somatic embryo. Once they get sufficient quantity of somatic embryos, they encapsulated the somatic embryos by using 3% sodium alginate, and they have got very good results. Next, please. For future use, next, please. Future use, this synthetic seed can be used as a seed plant drone for reforestation. Next, please. With this, I conclude my presentation. By employing synthetic seeds, the tissue culture raised plants can be regenerated on a simplified medium, eliminating subcultures, thus reducing the cost of operation. Development of protocol for direct recovery of plants from synthetic seeds under non-sterile condition may have a greater impact. Although a large number of plants can be produced in tissue culture through embryogenesis, multiple shoot cultures, their delivery is cumbersome. Embryos or shoots have to be separated singly and transferred for rooting to achieve root shoot balance, and the plants have to be hardened in greenhouse before field planting. Direct sowing of synthetic seeds in the soil does not need acclimatization, often enabling flexibility in handling and transport as compared to large parcels of these seedlings. Next, please. These are some future line of work. As synthetic seeds are poor storer, even in under low temperature, so there has to be need to study in the complexing materials which is used for encapsulation to increase storability of encapsulated seeds, and need to study the fortification of somatic embryos with encapsulating materials which ways to help in problematic soils. Next. Thank you UHSB, thank you organizer Sri Dhananjay sir, Suramji sir, and all the staff of the College of Horticulture, Mundrabad. Thank you one and all. Any queries, please?
Sir, thank you so much for giving glimpses about synthetic seed in horticulture crops, sir. With the permission of speaker, now this session is open for discussion. If any questions are there from participants, means you can unmute yourself and you can ask. Dr. Rajesh, sir.
Yeah. Hello.
Sir, really? Yes, sir, tell me.
Sir, what is the recovery percentage out of inoculated tissue, sir?
Recovery percentage is very less, sir, as we studied here in papaya, that is synthetic, sir, but most of the research, the recovery percentage is more than 60%, sir.
Okay, sir.
Castillo and in papaya, and Redenbug in alfalfa as well as in carrot. They got more than 60%, sir, recovery percent.
Sir, I'm Chitra. Sir, what is the seed storage life of the synthetic seed in case of
Madam, in ordinary refrigerator, it is less than 1 month, madam. But you have to need very sophisticated and modern seed storage structures, cold storages. Storage capacity is very poor, madam, in synthetic seeds.
Okay. Okay, sir.
Hello, sir.
Ah,
Sir, I'm Kotesh Lamani from ICR CCR Goa.
sir.
So it's
Sir,
very nice. Happy New Year, sir.
thank you, sir. Wish you to the
Nice
same, sir.
presentation, sir, and very informative.
Uh-huh.
Sir, my question is, how is the field performance of these synthetic seeds, sir, after direct field sowing?
Once it germinated in field, sir, the performance is very good, sir. The germination itself is a problem in open field condition. It requires special climatic condition. If the temperature is more in the summer season, it is difficult to germinate, sir. In such type conditions, we will prepare the seedlings in nursery and we will supply, sir.
Okay, sir. Thank you,
They will
sir.
supply.
Hello,
Hello.
sir. Good morning.
Good morning, sir.
Sir, what about the yield variation in tissue culture plants and this synthetic seeds plants?
The yield variation is not much the yield variation because you have take the expand from healthy mother plants, sir. Then there is no much difference in the yield variation compared to this tissue culture plantlets and synthetic seed, artificial seed plantlets. There is no much variations. Hello, can you hear me, sir? Hello, Tipeswamy, sir. Hello.
Yes, sir.
Okay, sir. Thank you, sir.
Okay, thank you, sir.
Okay, sir. If there are no questions from participants, means we will wind up this session. May I now invite Dr. Ashok Suryavanshi sir to propose a vote of thanks. Over to you, sir.
Okay. Thank you, Dhananjay. Thank you, Dr. Shivayog Rawat. He's presented very nucleus seed,
Synthetic seeds.
synthetic seeds with good PPT and had a brief about the advantage and disadvantages of on behalf of College University of Horticulture Science and College of Horticulture Bidar and organizing team. I heartfelt thank to the Dr. Shivayog Rawat for giving his nice presentation.
Thank you, sir, Ashok Suryavanshi, sir, and thank you, Dhananjay, sir. Thank you, Shivayog. Thank you very much, sir. Thank you all.
Thank you, sir. Thank you. And also, I extend my sincere thanks to all the participants for their patient listening to both the lectures. Today afternoon session, we don't have any lecture. We will rejoin tomorrow at 11 a.m. For the tomorrow session. Thank you, one and all.